Today we're starting Unit 8, which is the quadratic functions unit, and we're going to start by looking at just basic quadratic equations and how to solve them. So the first definition you need to understand is the quadratic function. What is it? It is any equation in the form fx equals ax squared plus bx plus c, as long as a does not equal 0. So that just means that in order for it to be considered a quadratic function, it must have an x squared term. If it does not have an x squared term, it is no longer a quadratic function. The graph of a quadratic function will always create a parabola. So here you can see a quadratic function will always produce a parabola when graphed with 0, 1, or 2 x-intercepts. X-intercepts are our values of x. So that means that whenever we solve for x, we are solving for the number of times the parabola crosses the x-axis. So here you can see in this first graph, there would be one solution because the parabola crosses the x-axis exactly one time right here. In this quadratic equation here, there would be two solutions because the graph crosses the x-axis twice. And here there would be 0 solutions because this quadratic equation never crosses the x-axis. This will become really important later on in the unit. For right now, just make sure you understand that parabolas are the graphs of quadratic functions, and that you can have 1, 2, or 0 solutions when solving for x. First, when solving for x. So now let's look at what happens when we're solving a quadratic function. We're going to look at some really simple examples, and then we'll go into some more difficult examples later on. So, to solve a quadratic equation, you either need to use FOIL or the box method. That's what we learned in Unit 5, so back in January and February. Or you need to use the properties of square roots, which we learned in Unit 7, just before spring break. Some important rules that you need to remember for this unit that were not critical in those other units are written here. First of all, whenever you have a radical sign, this will always give two answers, a plus and a minus answer. When we did this in Unit 7, we said we either used absolute value signs or we said we're just always getting the positive answer. However, here, now that we're thinking about the different solutions, the different number of times that a quadratic equation crosses the x-axis, it's really important that you always write plus or minus in front of your answer, showing that you know that there are two answers. So let's look at an example. The square root of 49. Well, we know the square root of 49 is 7. However, now we need to always remember to write plus or minus 7 because there are technically two answers, not just one. The other thing that we need to consider is negative signs under the radical. So in the last chapter, we just said you can't do it if you have a negative. That's because we hadn't introduced imaginary numbers yet. But now we need to think about imaginary numbers because our solutions can be imaginary. If there is a negative sign under the radical sign, the answers are imaginary. So anytime you see the square root of -1, it equals I. If we have an I next to our solution, it means it's imaginary. So what if this example then was negative, the square root of -49? We can split this using the multiplication rule that we used and learned in Unit 7 into -1 times the square root of 49. So we can split that up, and then that means that the square root of -1 is I, and we know the square root of 49 is plus or minus 7. If we put those together, we get plus or minus 7I as our answer. So you can see the difference now between the square root of 49 and the square root of negative 49. One produces two real solutions, and one produces two imaginary solutions. These are very basic rules that are going to be very important in this unit, so please make sure you really understand these rules. So let's look at a couple of simple examples. X squared equals 144. So one of the rules that we learned in our last chapter was that we always get x squared alone, and then we can take the square root of both sides. Those were the square root rules that we learned in Unit 7. So to solve this, x is already alone, so we can just take the square root of both sides. The square root of x squared is x, and the square root of 144 is 12. But now we need to remember to always include plus or minus in front. So this solution, or this answer, has two solutions, and those two solutions are plus 12 and negative 12. You could also write this as 12 and negative 12, but there's really no need. You can always just write it like this with the plus or minus together. Okay, let's look at one more, slightly more complicated example. Still not too bad though. So in this case, we're also being told to find x, but x squared is not alone. X is not alone. So the first thing we need to do is get x squared alone. To do that, we're going to subtract 200 from both sides. This will result in 2x squared on the left because these two cancel out, and negative 200 on the right. X squared is still not alone because 2 is being multiplied to the x squared here. The opposite of multiplication is division, so we're going to divide both sides by 2, resulting in x squared equals negative 100. Now we've got that x squared by itself, so we can take the square root of both sides. The squared and that root sign, the radical sign, cancel out, leaving just x. And on the right, we have another negative value. So remembering our negative rule, we're going to split this into negative 1 times, the square root of negative 1 times the square root of 100. And now we're going to take the square root of each. That means the square root of negative 1 is I. We always write the I after the number, so I'm going to write it over here so you know. And then the square root of 100 is plus or minus 10. So there's our two rules that we just learned put together in this problem. X equals plus or minus 10i, meaning that this equation has two imaginary solutions. Let's look at a different type of problem that you'll probably see in your homework tonight. This is when we're looking at the intersection of two graphs. Technically two graphs, not two lines. I say two graphs because in this case we have one quadratic function and one linear function. So technically we're looking at a parabola and a line that cross, and we're looking for the two places that these equations intersect. In order to solve this, we're going to set the two equations equal to each other and solve for x. The directions would say something like, find all x values where the following equations intersect. So find all x values where these two equations intersect. So when we set this equal to each other, we're going to get x plus 5 squared on the left because these are the same. So that means we're going to set this equal to this. So we have x plus 5 squared equals 3. Luckily, this is a perfect square, and so although x is not alone, it is part of a binomial that's being squared, so we can take the square root of each of these. That leaves x plus 5 on the left because the squared and the radical sign cancel out. And remember, whenever we take the square root of a number, we get two answers, so we're going to write plus or minus 3 on the right. Now we just need to get x alone. So that means we have x plus 5 equals plus or minus radical 3. We just subtract 5 from both sides. That leaves us with x equals negative 5 plus or minus radical 3. This is our final answer when being asked to find x. These are the two places where the equations intersect. This can again be written as negative 5 plus radical 3 and negative 5 minus radical 3. Or, of course, you can just write it like this. But you can see that there are two solutions. There's no i's anywhere, so there's no imaginary number. These are two real solutions.